Hey everybody, it's Mr. Anderson. Today we're going to get together and we're going to talk about section 3.3.1 from our CPM Common Core Algebra text. And folks, our job today is to expand on what we did in section 3.2 and use the idea of writing things as a product to expand into solving, right? We're not going to be able to do it all yet, but we're going to be able to go further than we were before. All right. We now know how to multiply and take things that are written in sums and write them as products. And we're going to go ahead and expand on that. We're going to review that to get started. And then as we continue, we'll use that to start doing some solving today. I have here on our notes, we're going to start here with section 331, problem number 376, and we're going to multiply the two expressions, and then I'll show you both the generic rectangle option as well as the distributive property that maybe we've seen prior to this. And this first one, 376, has me taking the binomial 6x and 11, negative 11, and 2x and 5, and multiplying those two things. And I'm just going to go ahead here, and I'm going to put one on the side, and then I'll put another one across the top here. And it doesn't really matter which one's which because, of course, multiplication is commutative. Now let's go ahead and actually do that multiplication, and it works out pretty cleanly here. For example, right down here in the lower left-hand corner, I'm going to be multiplying 6x times 2x. Right here, I'm going to be multiplying negative 11 times 2x. Right here, I'm going to be multiplying negative 11 times 5. And I'm using dot multiplication, but you could use parentheses or x multiplication, doesn't matter. And then lastly, it's 6x times 5. And folks, as we write these products, I'm going to go ahead and do it in an alternate color and larger so it stands out. In fact, I'll even make it a little bit bigger for us there. 6x times 2x makes 12x squared. If you're struggling with where that comes from, you might need to go back and review some of that multiplication and properties of exponents. Negative 11x times 2, or negative 11 times 2x makes negative 22x. And then negative 11 times 5 makes negative 55. And one more, 6x times 5 makes 30x. Okay, we're doing pretty well, but I can't just stop there. I've got to take these things and I've got to write them outside of this generic rectangle. And we usually write these things in order with the biggest degree first. I've got 12x squared, right? That is the only x squared term that I have, so no need to do any combining there. But these two items here are both terms that have an x in it, so they're combinable. I've got negative 22x and 30x. They sum together to be 8x, right? 30 minus 22 is 8. And then finally, nothing goes together with that, 55. So we're just going to stick with that as our answer. 12x squared, 8x, and negative 55. Okay, one more of these things, and I'll show you both options on this one. If you need to back up, check that other one out, and we can, how to put it, pause and replay and so on and so forth. Just for the sake of doing things differently, I'll write the y and the 2 on this side. If you like, write the plus 2 in there, that's fine. And then I'll put the 6 and the negative y across the top. Okay, and now, folks, I'm going to go ahead and just show this multiplication. All right, up here is simply going to be 2 times 6. Down here is going to be y times 6. Over here is going to be 2 times, I'll put this in parentheses because the y is negative, 2 times negative y. And lastly, y times negative y, right? Right in multiplication, a couple different ways there. Let's do this, and let's make it a different color. We'll make it stand out a little bit more. All right, y and 6 makes 6y, right? Multiplied, sorry, y times 6 is 6y. 2 times 6 is simply 12. 2 times negative y is negative 2y. That's just the way we write those products, right, with the coefficient first. I bring that leading negative out front. I don't write 2 negative y, right? As people might think that I'm subtracting. Negative 2y is our convention there. And then y and negative y makes negative y squared. Okay, ladies and gentlemen, now time to organize these things. I'll write it with that leading degree, or sorry, largest degree first, so negative y squared. These two items here will be combined. 2y, negative 2y, and 6y. That makes positive 4y. And then finally, that 12 just gets tacked on the end. Okay? So there's going to be our answer. And what does that thing look like, folks, if we have a multiplication using that distributive property? Because that was the other option they gave me. So let me just show you one of these. We know what answer we should come up with. I've got 6 minus y times y plus 2. Right? The distributive property is just a fancy FOIL. In this case, we're going to multiply that first term. Y times 6 is 6y. Y times 2 is 12. The inner, I'm sorry, FOIL. I said it. I didn't explain what it was. FOIL is a 4-letter acronym. First, outer, inner, last is what it stands for. I did the first term, the 6 times the 2. Or 6 times the y, sorry, 6y. The outer, 6 times the 2, the outer things in those parentheses. The inner, I'm going to do next, negative y times y is negative y squared. And then the last terms is what I'll do, negative 2y. Okay, and notice I have the same 4 terms that I have in that generic rectangle. The only difference is they're in a different order maybe. I can still write this with my leading, my largest degree first, sorry, and then I can combine these like terms, 6y and negative 2y to get positive 4y, and then my 12 is my constant term. And check it out. I know they're a different color, but they are the same thing. Okay, working backward and forward with the multiplication there really allows me to have a little bit more power in not only writing things differently but also in solving, and that's what we're going to go ahead and do here. I've got an example in number 3-77 to actually do some solving here, and this equation here has an opportunity to do the distributive property, and if you like that better, go ahead and do that. But I'm going to show you this example worked out with that left-hand side rewritten in the, how to put it, with it rewritten, the product taken from a generic rectangle. So I've got this set up already. I've got the 2 on one side. I've got the y minus 2 on the top there. I'm going to multiply 2 times y simply for 2y, and I'll multiply 2 times negative 2 for negative 4. Now, why does that help me? Check it out. Because now I can take it and I can rewrite it out here. And initially, while it maybe looked like a fairly complex problem, now that I rewrite it without those parentheses, now I don't have that restriction present. And now this is a simple 2-step linear equation. I can add 4 to both sides here. And I can, these cancel of course, I can say 2y equals, let's see, that's negative 2. And then I can divide both sides by 2. Let me see, I'll just do this real quick. If 2y equals negative 2, then I'll divide everything by 2 on the left, divide everything by 2 on the right, and I get y equals negative 1. All right? A little different way to look at that maybe allows you to think of things a little bit easier without those parentheses. When you have a monomial times a binomial like the one we had there, it maybe does not behoove you to do it that way. You could just do a simple distribution. But if you have a binomial times a binomial, it might. Check out B with me right here. Again, I set this up ahead of time. The left-hand side I'm not going to touch yet. You can see I'm making an effort to drop that left-hand side, the 5x plus 43 straight down. But look at that right-hand side. This right here is a binomial times a binomial. So I set up that 2 by 2 generic rectangle for the purposes of simplifying that. And that's what we're going to do to get started here. And 5x times x is 5x squared. 5x times negative 1, and in the box it doesn't matter, or in the rectangle it doesn't matter what order you multiply in. Just like if you were to FOIL and switch the O and the I around, it wouldn't matter. Okay, next is, let's see, x times 6, 6x, and lastly negative 1 times 6 is negative 6. Now let's go ahead and rewrite these, but before I do, I'm going to combine those like terms. 5x squared, nothing's going to go with that. 5x squared, all right. 5x, negative 5x and 6x makes 1x. And then lastly, I've just got a negative 6. All right, now check this out, because we haven't necessarily addressed solving a nonlinear item, but if I recognize I've got a 5x on both sides, look at how quickly this simplifies, right? I could take a 5x from both sides, and they literally just get eliminated. And I wouldn't have recognized that if I didn't do that multiplication. So I'm left with a 43 equals a 1x, or an x minus 6. And folks, I can add 6 to both sides, and I get x, or 1x equals 49. Okay? And I promise those things are checkable. You could go back up there and you could plug those back in to check. Okay? Let's move on to this last idea that we're going to cover, and I'm only going to have time to do one of these today, so feel free, because this might be brand new, this next piece, this absolute value piece, feel free to pause, stop, replay, take what you need. We're asked to solve something like this right here. We're asked to solve this kind of an equation in the next problem. This is 3-79 in your textbook. We're asked to solve the absolute value of the quantity 3x minus 5 equals 16. And I'm kind of throwing another question at you where we've got an absolute value problem here. The absolute value of x equals 5. This is very, very solvable. You may have seen something like this before. And what we might recall is we're saying when we set something up like this that absolute value is distance from 0. So we're saying there's a number, this number happens to be x, that is 5 units away from 0. Now this is going to have two solutions, because as you can see from my very simple number line, there are two numbers that are 5 units away from 0. They are both 5 and its opposite, which are 5 and negative 5. And that's what we glean right there. Now algebraically, this looks different, right? And it might require a separate approach to solving. In fact, I'm going to encourage you to split it the way I'm going to split it here. We're going to go ahead and we're going to set up that. And it's probably no mystery where that's coming from. All right? It is that item right there that it looks like I just dropped those absolute value bars. But I also have to consider the word I said a moment ago. Its opposite is also that far away. Okay? So it's going to be the opposite of that stuff on the left-hand side. And that's going to provide us with a second solution. Okay? Now, ladies and gents, I'm going to do this first part first. Here we go. We're going to tackle this with our typical inverse operations. Negative 5 and 5. Those items cancel out. I get 3x equals 16 and 5. Hey, 21. And now I'm simply going to divide by 3. And I get x equals 7. Yay! But if you stop there, folks, you don't have that thing completely solved. You don't have both options. Okay, I've got to consider this darker purple that I have over here on the right, because remember, there might be something that's that many units on the right-hand side, but I've got to consider the same thing, that is that many units on the left-hand side, right? You consider standing in a line. There might be somebody 2 people in front of you in line, but there's also somebody maybe 2 feet or 2 people behind you. Both of those people could be 2 people away. Right? Absolute value doesn't necessarily imply direction. Okay, last part here, we're going to solve this darker purple, and I will do so by distributing this negative. If you like, you could set up a generic rectangle, right? And I'll use the distribute property. That's like saying negative 1 times 3x, that's negative 3x, and the negative 1 times negative 5 is a positive 5. Okay? And check out what we got there. All right, now let's go ahead and do some solving. This time I'm going to subtract. These processes, these problems look so similar, but they are not the exact same. Okay, we're going to cancel these on the left. I get negative 3x. That works out to be 11, right? Because 16 minus 5 is 11. And then finally, I'm going to divide both sides by negative 3. And ladies and gents, a calculator is going to work just fine here. If you want, you can write this thing as a fraction. But this works out to be negative 3.6 repeating. Okay? Folks, this idea might require a little bit of time to mentally digest, right? But the key takeaway is that we've got 2 distinct solutions. And then notice that the solutions in the side note over there were opposites, but the solutions right here were not. It does work out where occasionally they are, but they're not always. Hey, check out this review preview, 81, 83, 84, and 85. Let's get after those things. Let's try some of them, and let's learn and try to improve. Ladies and gents, thanks for watching. Have a great day.